stress.
Okay.
Yeah, positive.
Okay. This is the limit for the steel. If stress will increase, if stress will be more than this.
Да, получается, это не выдержит.
Yes. So the reason, because we are equalizing, is that we are trying to find positive yielding bending moment. Okay? Here it's written, calculate the positive yielding bending moment.
A positive means tension.
Positive means bottom rebars are stressed, which is tensed. So yielding, it means that the rebars, bottom rebars, they already reached their yielding capacity. So that's why we are using, for the stress, we are putting the design yield strength of steel, because it's already yielded. Okay, is it clear?
I got from the point that if it's more than the design one, then it's not gonna work.
Yes, that's correct.
Okay.
So it means that design one is already the maximum that it can handle?
No, design one is not maximum, it's design, it's already decreased. Because we want to be on the safe side. The maximum one is FYK, 450. But we will not use 450, we will use 391, because we have this safety factor. Here, it's also mentioned here, steel safety factor. So we are decreasing the yield strength of steel by 1.15. So it means our stress strain law will have so here you have epsilon, that's sigma. Here you have Fyk, and here you have Fyd. Is it clear? When steel reaches this point, which is yielding point, you see, in a constant stress, stress is constant, stress is not changing. Stress is constant, but you have elongation. Is it clear? It is like a gun. You put the constant stress, but it will elongate. It's like a viscous material. So when it reaches the yielding capacity, it will behave like it.
It will have elongation and you will not take more stress?
Yes. I mean, if you keep the stress constant, it will elongate. I mean, it will not have certain resistance to the stress. Okay, it's already yielded. But it didn't fail, it didn't break.
Yet.
Yes, it didn't break, but it's acting like a gun, like steel. So this is the yielding point. So this yielding point is equal to sigma S1 because we want to find the bending moment, which will create tension that will make steel to yield. So now we have Fyd.
Вы стираете?
Oh, no. I was going to. Is it visible?
Yes.
Now let's calculate the FS1. FS1 is equal to 391 megapascals multiplied by AS1. 1.286 square meters. Can you repeat 400?
491,478.26.
2 newtons. So this is 491 kilonewtons. Now, FS2. So FS2, we will assume that it will be yielded. We don't know if it's yielded or not, but we will assume. Okay. So if we assume that FS2 is also yielded, it will be equal to 491 kilonewton. But it's minus.
Why do we?
Oh, sorry. It's not equal. But the calculation is the same. So we have 391 megapascal multiplied by area of the top reinforcement. 314 square millimeters.
It will be 122,669. 122 869 .56.
1.5. So it's equal 1, 2, 3 kilometers. C. So the force coming from the concrete, only from the compressed part.
Times B times YC and times sigma CT.
So force coming from the concrete is equal to the 0.5 times B times YC
Times sigma
and multiplied by sigma C. Why we are taking 0.5?
The half part. It's something given, if I'm not mistaken, only these three parameters we can.
Yes, but 0.5 is also assumed. Why we are assuming 0.5? Because
Only half of this force.
yes, it's this is your section. Here you have FS1. Here you have FS2. Then you have C. C is actually will be somewhere here because it will be a resultant of the concrete. It will be a resultant of C. So at the first iteration, we are assuming that C is just a uniformly distributed load, where the resultant is equal to the 0.5 multiplied by YC. This is YC multiplied by B by sigma CT. Is it clear? This is assumption, our first assumption. But in reality, it will not act like this. It will act in a parabolic way. Okay. So that's why you don't know how to find the resultant of this parabolic stress pattern, right? So in order to find, you have beta 1 coefficient, which is coming instead of 0.5. Is it clear? If you have questions, please ask.
But to simplify, we always use 0.5.
It's not to simplify, it is because we cannot solve it if we will consider beta 1. Because we will have two unknowns, one equation. Here you can see. You have C, you know fs1, you know fs2, right? But inside C, if you have beta 1 multiplied by yc multiplied b sigma cd, you will have two unknowns, but one equation. So we cannot solve it. So that's why it's iterative process. At the first, we are taking beta 1 equal to 0.5. So now, for the C, we will use this equation for the first iteration. So now it's equal 0.5 multiplied by B, which is 450, multiplied by C, sigma CD.
The sigma CD is 16.6. Because concrete with 25 and 13, we take 25 and divide it by 1.5.
Okay. Is it clear?
It's really
We have concrete class C25, 30, right? Concrete class is C25, 30. Safety factor for the concrete is equal to 1.5. So sigma CD is equal to the FCD. I mean, ID is the same. This is the design compressive strength of concrete. So from the Eurocode, there is a table. You can use the table or you can use some equations. Sigma CD for the C2530 is equal to
25.
FCK over 1.5. Okay, FCK is 25. FCK is a characteristic compressive strength of concrete. Cylinder. Okay, it's a cylinder. 25, 1.5. So it's equal to 16.6, right? Megapascals. So now I will use here 16.6.
Это будет 3750 умноженное на весе.
So this is in megapascals, this is in millimeters. So maybe you don't need to calculate now because we will substitute in equation. Okay? So we have 0 is equal to C plus Fs. Fs1, and as you said, minus Fs2. Please note that I'm putting here minus. It means for the Fs2, I have to put positive number. Fs2 is compressed.
Shouldn't Fs2 be negative?
In the correct way, it should be plus, and Fs2 when we calculated FS2, it should be minus. Okay, because it's compressed. Then we will substitute here minus, so it will be minus. But now I wrote here
Minus because our FS2 was positive.
yeah, I wrote minus because here FS2 is not positive. First of all, FS2 is negative because it's compressed. So it shouldn't confuse you because it should be minus here. Now let's write sum of forces, okay? Do not write minus. It's clear, more clear in this way. Because we will substitute minus and it will be minus. So FS2 is so now we have 0.5 multiplied by C multiplied by 450 multiplied 16.6 plus FS1. What was the value of FS1?
Minus 391, что ли?
Нет.
491.
491 and the minus FS2.
123.
1, 2, 3. So now we need to find YC.
YC is equal to
YC is equal to minus 491
plus
plus 1, 2, 3 divided by 0.5, 450, 16.6. So we check, this is in kilonewtons, this is in kilonewtons. So please, this one should be newtons. You have to multiply by 1000. And this one also. Because they are in kilonewtons.
Minus 91.5.
да, minus 98.1.
98.5.
Let's take minus 98.
Okay.
So now we know YC. Right? Now we will calculate the force acting on the top rebar again by considering the neutral axis. We have we know YC. We want to find sigma S2 or sigma C. Sigma S2, sigma S1. We will find these values again. Because we know YC. So the contribution of the concrete maybe it will change. So that's why we are finding it again. So what is the value of sigma S1?
391.
For the second, I mean, this is not second iteration, it's still first iteration. Okay. Second iteration will be when we change the neutral axis.
123, которое было.
So sigma S1 is still bottom rebar, and it is still yielded.
491.
So it's still equal to 391 megapascal, right?
Нет, 491 же мы написали там.
No, I need sigma. Please, I need stress. 391 megapascals. So I know sigma S1 and I need to find sigma S2. So you can find the curvature down x. This is YC, this is D1.
Надо curvature еще так можно. DC найти.
No, we don't need. Curvature is the slope. Okay? Curvature is the slope of the what's the angle of the slope. So it's equal to the YC divided by sigma C. Now let's find for the sigma S2. Because for the sigma C, we will use beta coefficient. Okay, so we have S1. You will have 1C, we know 1C. Then we'll have D1. So if we do, so D1 divided by sigma S1 right? It will be equal to YC minus D2 prime
Divided by DC1.
divided by sigma S2. You can write it as epsilon, like we did last time. Strain, in terms of strains. Now I'm doing for the stress, because they are linearly related. Because we are using this equation, I can just substitute epsilon with the sigma. Is it clear?
Да.
I can write here epsilon, if you want, epsilon S1. Is it more comfortable for you? Because it will be same with the previous exercise.
Я еще ближе. Сегодня.
So please find here sigma S2. What is the value? It should be D1 minus YC. So D1 minus YC is 252 minus
98.
98. Can you recalculate?
139.6.
139.6. 140
30.
megapascals. So now we know the stress in the bottom rebar, at the top rebar, which is actually in our first iteration, we have stress acting at top rebar is 140 megapascals. You see, it is not yielded actually. Yielding is 391. So now we need to find stress at the concrete at the top. here we cannot use this relationship because sigma we would stress in the concrete and the rebar, they are in a because materials are different, we cannot use the relationship for the stress. Okay? We will find strain. Is it clear? So we have sigma c. I will put here epsilon c. We have epsilon s1. Now if you write, if I write in terms of strain, the similar relationship linearly, we will have yc divided by epsilon c. Is it correct? Will be equal to d1 minus yc divided by epsilon s1.
Then shouldn't it be yc minus d2? Why?
Could you repeat?
Because in the first case, we subtracted the d2 prime, and now with epsilon, when you wrote yc over epsilon c, you didn't subtract d2 prime.
Yeah, because epsilon c, I'm finding the strain at the top fiber, most compressed fiber.
And in the case of stress, we were finding.
No, stress is sigma s2 is in the rebar. Stress is acting here, sigma s2, because rebar is here. This is concrete.
Ah, okay.
Is it clear?
Yeah.
Like, this is your section. This is your neutral axis, YC. Here you have rebars.
Yeah.
And this value is d2 prime.
Mm-hmm.
Okay? So sigma s2 is here, center of the rebar.
Yeah.
So that's why it's d2 prime.
Yeah.
But now we want to find for the
Concrete.
concrete. That's why it's YC.
Mm-hmm.
So can you calculate here the epsilon c, please? Epsilon c is equal to please also note that concrete will be compressed. So epsilon c is negative because it's not tensor. Strain is the elongation. But we have opposite of the elongation now. No, it's we will just put minus. 248.
Epsilon mogen we eens gaan bepalen. Epsilon S1.
S1.
Or we should multiply by the.
But how did you calculate? How did you calculate epsilon S1?
Я готова взяла.
Я смогу все.
391.
But we should
No,
do
it's
like
epsilon.
linear.
She's
Yeah.
correct, yes.
Приравняли.
You need to
No.
find first epsilon S1, which is equal to sigma S1 divided by E S.
Ой.
And do we have ES?
This is this equation, stress strain law.
No,
You
yes,
have
I know.
Young's models.
But we don't have Young's model.
No, we have it.
Ah,
So Young's modulus is 210 gigapascals.
Его в омега нужно перевести.
Yes, please. It should be in megapascals. So the strain is equal to, do I have here strain? Small.
0.00.
Да.
Calculate.
Ну, 2 может быть.
391 divided by 200.
Ниже 1.86 multiplied by 10 to the power of minus 3.
This is the strain. So now please calculate epsilon c. We'll have epsilon s1 strain in the bottom rebar.
Если мы снизу распустим
EC
Y.
epsilon c.
Нет, YC. Y.
YC here is plus. In the equation is plus. If you want to use with the coordinates, you have to note that here you will have 0. Okay, so
It will be 1.18 multiplied by 10 to the power of 3 minus 3.
so 1.18,
18.
1.19,
18.
18, e minus 3.
3, yes.
So this is negative. So now we know epsilon c, and in order to find beta 1,
Ну, представляем.
let me share my screen, which is taken from the
Ну, по EC умножить на 6 минус EC.
Yes. Just a moment, I will share my screen.
We put minus for epsilon c because it should be
It's compressed.
compressed.
Concrete is compressed. You have positive bending moment. Okay, you are trying to find positive bending moment. So that's why top is compressed. So now, here is the beta 1 parameter. Please note that it is calculated from this integral for the compressed part of the concrete. You see, C is equal sigma C from 0 to YC, and it is using beta 1 because it is not linear load, it is parabolic. So that's why there is the coefficient of beta 1 which takes into account the parabolic load pattern. So it is called beta 1 is non-dimensional result of the integration. You can say that it's non-dimensional factor for the concrete. So you can note these two equations, beta 1, and depending on the range of your EC, epsilon C, we will use one of them. Okay, if your epsilon C is between 0 and 2, we will use first one. I wonder if Professor shared this PDF. Do you have it? So you can just take notes from this part of the PDF. Then this is a non-dimensional factor. Okay? It is derived from the stress-strain law for the compressed part of the concrete because it is not linearly distributed load. It is parabolic. You don't need to derive it. You will always have it. Okay? So just you need to know how to use it. Now, beta 1 actually I now remember the equations. Epsilon C 12, and this is for epsilon c 2 from 0 to 2, right? Then we have beta 1 is equal
3 epsilon c
3 epsilon c
minus 2. No, it's
minus 2
over 3
3 epsilon c from 2 to 3.5. So epsilon c is equal minus 1000 multiplied by epsilon c. It's given to use the strain that you have in the concrete. Just so which one do we use? First one, right? Because our epsilon c is 1.9. So beta 1 is equal to
our epsilon c is 1.2. By 1.2.
1.9, 6 minus 1.9 divided by 12 is equal to
0.65.
0.65.
Our epsilon c was not 1.9.
It was 1.86 multiplied
Oh.
by minus 3.
Yes, it's 1.918. So please recalculate.
0.47.
0.47, is it correct? You all have the same answer?
I trust.
So you can take 48 or 47, doesn't matter.
No.
So we have beta 1 multiplied by yc multiplied by b multiplied by sigma cd. So this is the force of the concrete, resultant force of the concrete. You see 0.5 is replaced by beta 1. So now it will be equal to 0.48 multiplied 450 multiplied by yc.
Twice 98.
98. Then we have sigma CD 16.6. So please note that this will be minus. So you can put this minus from the YC actually, because YC is minus. Yes, exactly, 251. So this is C, resultant of concrete. Okay? So now we will do, we will find NRG, which is resistance of the section to the axial force.
Resistance of the section.
Yeah, it's NRG. It's just the sum of the three resistance that we have. So NRG is C plus FS1 plus FS2. So we have, this is the resistance of the section to the axial force. We have minus 351 plus FS1. What is the value of FS1?
FS1 was minus 103.
FS1 is 391. 391 kilonewtons and minus FS2 123 kilonewtons. So FS2 is equal to sigma S2 multiplied by E, right? Sorry, AS2. AS2. sigma S2 is minus 140 megapascal multiplied by
240.
314 millimeters squared.
43,960.
So it is
43,960.
44 is okay. Minus 44 kilonewtons. So now we'll use this FS2 because it's practically this is our second iteration, but we are assuming that it's the first one. We didn't write any iteration number. So we have here not 123, but FS2 that is yes 44. I mean FS2, which is coming from the real case
96.
when the force from the concrete is coming in the parabolic pattern, and we are not assuming to have it yielded. It is not yielded. It's only 44. So
96.
we have 96. So we have 96 kilonewtons. Now we know the NRG is equal to 96 kilonewtons. Our axial force, external force, is equal to 0. Okay? We don't have any axial force. Now we will compute the error. So the error was equal to MED minus NRG divided by sigma CD, right? Sigma CD. Was it C? Just C.
C.
It's just C. So we have minus 96 divided by C, which is equal to 351.
Zero point 27.
0.27, which is 27%. So this error should be less than 1.
Yes, yes.
If it is not less, no, what less than 1%.
1%.
Okay. Now we have error 27%. So that's why we will calculate new neutral axis, YC, which will be equal to Y0. Y0 is our first neutral axis, okay? Don't be confused. This is YC, let's say write new. This is old. Okay? Plus, here we will add the NED minus NRG divided by, so it should be B FCD, B sigma CD. So now we have, please calculate new YC, new neutral axis.
И все заново то самое решать?
Yes,
До какого?
until we have error less than 1%.
Instead of Y C old, we should substitute the YC that we used.
Our first YC that you had, it was minus 98, right? Please also write here minus 98. Actually here I have, there is no module, I mean, it is not absolute value. Sorry, my mistake. So here you have NED minus NRG. So it will be minus 96 divided by B is 450, right?
Yeah.
Multiplied by sigma CD, which is 16.6. So it is equal to please note that 96 is kilonewtons. Okay? This one is also kilonewtons, but this one is newtons. I mean, this is it was my mistake. Yeah.
Because we're going a little bit fast.
This is YC old.
Получается минус 110. Запятая 85.
So minus 110.8
0.85.
millimeters. So now we have new neutral axis, and we will repeat the process for the new neutral axis. What is the process? We have to find
Sigma.
C, we need to find FS1, we need to find FS2. The process is really clear, we already did it. So I need someone who will solve it on the board, so that we will solve it together. Okay? YC new is equal to minus 100. Let's make it 111. So